Assalamualaikum and hi everyone. In this video, we will continue topic 3 part 2 for the subtopic 3.5 to 3.9. Subtopic 3.5, which is about the resistor in series and parallel. Figure 1 and figure 2 shows the example of the arrangement of resistors in series. When resistors are connected in series, the same current flow through each resistor given I1 is equal to I2 and equal to I3. For the potential difference, total potential difference between the resistor is equal to the sum of potential difference V1, V2 and V3. While for the effective resistance, it is equal to the sum of R1 plus R2 and plus R3. Here are the example of resistors connected in parallel. Since the three resistors are connected in parallel, the potential difference across the three resistors are the same, represented by V1 equal to V2 equal to V3. For the current that flow through the junction, this current will divide into three junctions. So to calculate the total current, it is equal to I1 plus I2 and plus I3. And for the effective resistance of the parallel arrangement of the resistor, we will refer to the equation of 1 over R effective is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Subtopic 3.6 is about Kirchhoff's rule. Kirchhoff's first rule states that the algebraic sum of the current entering any junction in the circuit must equal to the algebraic sum of the current leaving the junction. It is also known as junction rule or current rule. This is the example of the Kirchhoff's first rule. A is a junction, and referring to the junction A, I1 and I2 are entering the junction and I3 is leaving the junction. So we can write down that the equation for the Kirchhoff's first rule, I1 plus I2 equal to I3. Kirchhoff's second rule states that in a closed loop, the algebraic sum of EMF is equal to the algebraic sum of the product of the current I and the resistance R. It is also known as the loop rule or voltage rule. There are three important steps to apply Kirchhoff's rule. I will explain in the example after this. Take a look at the example. First, identify the direction of current at the junction. So you can choose one junction in the circuit and label the direction of current at that junction, either entering the junction or leaving the junction. Second step is you label the direction of the EMF, and to take note that the direction of EMF is from negative to positive terminal as shown in the diagram. Third step is identify the direction of loop. Loop 1 is clockwise following the direction of EMF1. Loop 2 is counterclockwise, same direction with EMF2. After identifying the direction of current, direction of EMF, and also the direction of loops, we can apply the Kirchhoff's first rule, which is at that junction, I is equal to I1 plus I2 because of I is entering the junction, I1 and I2 is leaving the junction. We will apply Kirchhoff's second rule for the two loops to obtain two equations. The direction of loop is used to identify the sign of current and EMF. Current and EMF in the direction of the loop are considered positive and vice versa. Then solve the simultaneous equation using calculators. Subtopic 3.7 is about the electrical energy and power. When the current flows through the bulb for time t, charge carries from point B to point A given by the equation of Q is equal to IT. The work done on the charge Q to bring from point B to point A is equal to the electrical energy, represented by the equation of W equal to VIT. The electrical power is defined as the energy dissipated per unit time in the electrical device. It is given by the equation of P is equal to VI. For the power loss or power dissipated through the resistor, the equation for P is equal to I square R or V square over R depends on the given information in the question. Subtopic 3.8 is about the potential divider. Principle of potential divider. If we need a voltage lower in our circuit than the voltage source, we can use a voltage or potential divider. This is done by connecting two or more resistors in series. The nodes between the resistors will have a lower voltage compared to the input voltage. Since the current flowing through resistor R1 and R2 are the same, we can calculate the potential difference across R1 using the equation of V1 equal to R1 divided by R1 plus R2 times with V, which is the supply voltage. Last subtopic is about the potentiometer. The basic principle of the potentiometer is the potential drop across any section of the wire will be directly proportional to the length of the wire for the uniform cross-section area of the wire and the uniform current flow through it. Potentiometer consists of a driver cell called accumulator with negligible internal resistance connected to uniform wire AB, normally 1 meter long. The potentiometer is balanced when the jockey at a position where no current flow through the galvanometer. When the potentiometer in balance, unknown voltage, which is Vx, being measured, which is equal to the voltage across AC. There are three applications of potentiometer. The first one is compare the EMF of two cells, measure an unknown EMF of a cell, and also measure the internal resistance of a cell. How to compare the EMF of two cells using the potentiometer? From the circuit given, when switch S is connected to terminal 1, EMF1 is connected to the potentiometer given the length of the wire L1. When switch S is connected to terminal 2, EMF2 is connected to potentiometer given the length of wire L2. From the value of L1 and L2, we can compare the EMF of these two cells. To measure an unknown EMF of a cell using potentiometer, let we assume we want to measure EMF2. By using the same circuit, we need to replace EMF1 with a standard cell which provide a constant and known EMF. Then we do follow the same step as in the first application to determine L1 and L2. And by using the same equation, we can measure the unknown EMF too. The third application is to measure the internal resistance of a cell. You will learn this application in the experiment 3, which is about the potentiometer. Okay, everyone, that's it for this topic. Thank you for clicking button like and don't forget to subscribe my channel. If you give comment and share this video with your friends, I really appreciate that. Okay, Leslie, thank you for listening. Good luck and I wish you all the best.